Concrete. Highway construction calls for a lot of it, and it has to be high-quality material. If you could take the concrete out of this structure, what you'd have left would be, basically, a lot of reinforcing steel. From the bottom up, it's concrete, piling, footings, columns, caps, beams, deck, and railing. We use concrete extensively, in bridges, of course, but also in pavement, culverts, barriers, and retaining walls. And the list goes on. Because of the various uses for concrete, there are different classes of the material. Each class of concrete is based on a different design. That's why testing is necessary, to make sure that the mix that was specified by the designer is delivered to the job site, and to make sure that the concrete is mixed consistently. A problem at the plant will show up in the field test results. That is why the inspector's on the job, to make sure the department gets the quality it pays for. Here are the major tests: temperature, slump, compressive strength, and air content. This program, Part 1, covers the necessary preparations, sampling concrete, and checking temperature. Part 2 covers testing the concrete for slump and casting cylinders for compressive strength tests. And Part 3 deals with air content tests. Okay, let's get going. Preparations. But first, a couple of quick notes. Before the work begins, discuss the procedure for sampling and testing with the contractor's representative. Make sure there's an understanding about the timing and methods of obtaining samples and running tests. Okay, before any concrete is delivered to the work site, make sure you're ready for it. For example, if you're patching, is the base well compacted? Stable? Are the forms and reinforcing bars in place? If the job is really well coordinated, the concrete will be placed as soon as the truck arrives. So check the job site. And the testing equipment. You'll be running slump tests and air content tests. And you'll be casting cylinders. So make sure the equipment's on hand, in good shape, relatively clean. And for air content tests, make sure the meter has been calibrated recently. When the first truck arrives, the driver will give you a delivery slip. That's your verification that the correct concrete design is being mixed. Check the class of concrete and the water and cement content. Among other things, the delivery slip shows the amount of concrete in the truck, the time at which it was batched, and the reading on the truck's revolution counter. Double-check the class of concrete. Save the delivery slip. That's part of the project documentation. You get one for each load. The time is critical. Concrete must be placed within 90 minutes after mixing. So if the concrete was batched at 2 o'clock, it must be placed by 3:30. The revolution counter on the truck records each revolution of the drum at both mixing and agitating speeds. The concrete will start to segregate if it's mixed too much, so it's important to keep an eye on the counter. The counter reading on the delivery slip was taken when the concrete started mixing, if it was truck mixed, or when the concrete was placed in the truck, if it was plant mixed. Before the concrete is placed, read the counter, and read it again at the completion of the discharge. Then record the total revolutions on the delivery slip. If it's truck mixed concrete, it has to be mixed between 70 and 100 revolutions at mixing speed, and no more than 250 total revolutions, counting both mixing and agitating revolutions. If it's plant mixed concrete, there are mixing time limits for the central mixer. But the same 250 total revolutions limit applies for the hauling units, whether they're truck mixers or agitators. Okay, that covers preparations. Make sure the work site is ready. Check the testing equipment. It should be in good shape and recently calibrated. Collect all delivery slips and record the total mixing water added and the total revolutions on the slips. Now on to sampling. Getting a sample of concrete to run the tests on. Actually, the word sample isn't quite enough. What you're going for is a representative sample. You want to make sure the concrete that you're testing is typical of the entire truckload. The basic rule in sampling concrete is this: don't take the sample from the beginning or the end of the discharge. At least 3 separate samples have to be taken. I'd suggest taking them at about the 1/3, 1/2, and 2/3 points. Either catch the entire stream in a container or swing the chute over to the side. The important point is this: get the entire stream. Be sure to get enough concrete to run all of your tests without reusing any of it. Cutting the stream in half like this is unacceptable. The rim of the bucket will knock some of the large aggregate out of the sample. Remember, a reliable test calls for a representative sample. The sample should be mixed with a shovel, just enough to give it a uniform appearance. Then it should be covered to protect it from the sun and the wind. Don't let it dry out. One last point in sampling: check the time. You have 15 minutes to run the testing and cast the cylinders, if they're going to be made from this load. And that covers sampling. Now, temperature. Temperature affects concrete the same as it affects people. It can freeze and it can overheat. Neither is acceptable. In concrete work, temperature is always a concern, both the air temperature and the temperature of the concrete. Of course, the air temperature affects the concrete temperature, and the concrete can't withstand extreme highs or lows. In structures, concrete has to be between 60 and 90 degrees Fahrenheit. In paving, the range is 50 to 90. The concrete temperature determines the time allowed between batching and placing, and the air temperature determines whether to use normal curing methods or special cold weather curing. Checking the concrete temperature is simple. Just insert an approved thermometer into the sample, wait 10 or 15 seconds, and read it. Record the temperature on the delivery slip. That's all there is to it. And that completes part 1 of the series on concrete sampling and testing. Preparations, sampling, and checking temperature. When you're ready, go on to parts 2 and 3. Field Testing Concrete, Part 2. This program covers the slump test and casting cylinders for compression testing. We'll start with the slump test. Basically, the slump test consists of filling a standard slump cone with concrete, rodding it to consolidate the concrete, then lifting the cone off, and measuring how far the concrete slumps down when it's not supported by the cone. The slump test is a measure of 2 things: uniformity and consistency, and it indicates how workable the concrete is, whether it's relatively stiff or more fluid. Here are 2 examples with different slumps. It's a bit confusing to beginners, but you'd refer to the one on the left as having a high slump. The one on the right has a low slump. When you think about it, it makes sense. The concrete on the left slumped farther, so it has a high slump measurement. The procedure that you'll see here is based on test method number 804. The construction manual covers the procedures and the equipment used. You need to run one slump test for every 100 cubic yards of concrete placed. To run a slump test, you need first a rigid, stable base that won't absorb water from the concrete sample. A wet piece of plywood is fine. Just make sure there's no freestanding water on it, because that would affect the concrete. Second, a standard slump cone. It should be reasonably clean with no major dents. Make sure the inside is smooth. No dried concrete. Third, the tamping rod. Make sure it's the standard rod, made for concrete testing. It's not acceptable to use a cut-off reinforcing bar instead. The bar has to have a rounded tip, so that the large aggregates aren't pushed to the bottom when the concrete is being rotted. Next, a scoop. The kind with a rounded bottom is best because it makes it easier to get the concrete into the cone. And finally, something to measure the slump with, a ruler or measuring tape. And that's all the equipment you need. The base, the cone, the rod, a scoop, and a ruler. Now for the test procedure. To begin with, of course, you need a sample remixed until it looks uniform. Dampen the inside of the slump cone so the concrete won't stick to it. And dampen the base as well. But remember, no freestanding water. Place the cone down on the base, as close as possible to the concrete sample. Make sure the base is level and firmly supported. It has to be flat and stable. That's a must. The person doing the test should step onto the footholds at the bottom to hold the cone steady and stay there. That's why the cone should be close to the concrete sample. Now we can start filling the cone. It's best to move the scoop around the top to get the concrete distributed as evenly as possible. The cone is filled and rotted in 3 layers by volume, not according to the height of the cone. The first layer should come up about 2.5 inches. The second layer should come up about 6 inches, about halfway up the cone. And the third layer should overflow. To make it easier to get the right depths, some people mark the outside of the cone at the 2.5 inch and 6 inch levels. They don't have to, but it does make the testing more accurate. Okay, he has the first level in the cone. Now rodding. With the rounded end of the rod downward, he rods the concrete 25 times, starting at the outside, spiraling toward the center. And he's rodding deep enough to just tap the base. Now notice one thing. When he's tamping at the outside edge, he holds the rod at an angle so it's just about parallel with the side of the cone. That's the way to do it. If he held it vertically, he'd miss the edge. It wouldn't get rodded properly. Now he's ready for the second layer. Again, it should reach about half of the cone's height. The second layer is rodded just the same as the first. 25 times, starting at the outside and spiraling toward the center. But one difference, he doesn't rod to the full depth of the cone. The rod should go just deep enough to penetrate the first layer by about 1/2 inch. And there's an easy way to make sure the rod goes to the right depth. Just grip the rod at the right distance from the bottom tip. 12 inches for the first layer, 10 for the second, and 6.5 for the third layer. And rod downward until the hand just reaches the top of the cone. Marking the rod at the 12, 10, and 6.5-inch points can help you to position your hand quickly and correctly. Okay, ready for the third layer. As I said earlier, the third layer should overflow the cone. The concrete should stay above the cone throughout the rodding. If it drops down, stop rodding. Add concrete, then finish with the 25 spiraling strokes. No more than a total of 25 though. The rod should penetrate the top of the second layer by about a ½ inch. The cone's full and the rodding is done. The next step is to use the tamping rod to strike off the concrete at the top. The top should be fairly smooth, so it's best to use a sawing motion and roll the rod at the same time. There, level and fairly smooth. The next step is to remove any concrete that is spilled around the bottom of the cone. That's important because any concrete down there will keep the sample from spreading out when the cone is lifted off. Now the cone can be removed. Notice that he places both hands on the handholds and presses downward to keep the cone stable while he takes his feet off. If it's done improperly, removing the cone can ruin the test. Here are the rules. Pull straight up with no twisting or tilting allowed. It should take about 5 seconds. It takes a steady upward lift, slow enough so the concrete doesn't pull on the cone. Now set the cone down next to the concrete, being careful not to jar the plywood base. Lay the tamping rod flat across the cone and measure the distance between the bottom of the rod and the top of the concrete. Measure to the nearest 1/4 inch. You'd record this as 1 3/4. Now here's an important point about measuring. Measure from the bottom of the rod to a point on the concrete that is directly above the center of the bottom of the concrete, not at the center of the top. If a fair amount of concrete falls off or shears away, the test is invalid. Make a new test using another portion of the sample. And that's the slump test. On a stable, flat, non-absorbent base, fill the cone in 3 layers by volume, not by height. Rod each layer 25 times, spiraling toward the center. Strike off the top layer. Clean around the base of the cone. Lift the cone straight up without twisting or tilting it, and measure from the bottom of the rod to the top of the concrete, directly above the center of the base of the concrete. There's a time limit too. 2.5 minutes between the point where he starts filling the cone to when he measures the slump. Always document the slump measurement on the delivery slip. If the slump is not within the range that's called for, discuss the deviation with your supervisor right away. And of course, after the test, the equipment should be rinsed off, especially the rod and the inside of the cone. Then it'll be ready for the next time. Now, on to casting cylinders in the field. Again, casting, testing equipment, and methods are covered in the construction manual, Test Method 809. First, the equipment needed. Standard cylinder molds, a tamping rod like the rod used in slump testing, and a scoop or a blunt-ended trowel. As part of the preparations, make sure there are enough cylinder molds on hand. You will need to make at least 2, and more if the pour will be over 50 cubic yards. The procedure for casting cylinders is very much the same as the slump test. 3 equal layers of concrete, rodded 25 times in the same spiral pattern. You'll need a random sample of concrete, as you saw in part 1 of the course. Be sure to get enough concrete to run all your tests without reusing any of it. Place the first layer into the mold, moving the scoop or trowel around the lip of the mold. If the concrete isn't distributed evenly inside the mold, use the tamping rod to move it around. Rod it 25 times, spiraling toward the center. Full depth for the first layer. Place the second layer and rod the same way, but deep enough to penetrate the top of the first layer by about 1 inch. You'll recall that slump tests call for a penetration of just a ½ inch. If the rotting leaves holes in the concrete, you should pat the sides of the mold with your hand, very lightly, to close up the voids. Then for the third layer, overfill the mold. Then rod the same way, an inch or so into the second layer. Strike off the excess concrete with a trowel or a straight edge, using a sawing motion. Mark the contract number and the cylinder number on the side of the mold with a black felt tip pen. Number the cylinders sequentially, from the beginning of a job to the end, for each class of concrete. Be sure to record the numbers in the cylinder book. You have to know where to find the concrete that the cylinders represent. Cylinder curing is a critical part of the testing. Try to keep all cylinders undisturbed for the first 24 hours, buried with dirt within 2 inches of the tops, covered with the caps supplied with the cylinders. But that's not all, because there are variations, which your instructor will discuss after the program. There's one point that I can't stress enough. Be familiar with the specs and the construction manual, and make sure that your references are up to date. Know the project that you're working on, and the concrete mix design that it calls for. There's just no way to do a thorough inspection without having good references on hand. And that covers Field Testing Concrete, Part 2. If the average person is asked what Portland cement concrete is made of, he'll probably think of stone or gravel, sand, cement, and water. But the last ingredient that most people would think of is air. That's right, air. All concrete mixtures have some air, from voids in the aggregates that are trapped in the mix. But nowadays, air is intentionally added or entrained in most concrete to improve its quality. An air-entraining cement or add mixture produces billions of microscopic air bubbles throughout the concrete. This makes the concrete more workable, more durable, because it resists the effects of freezing, thawing, and de-icers, and more watertight. And it can be just as strong as non-air-entrained concrete. In Washington, the specifications call for an air content of 5% by volume and accept results of from 1.5% below that to 1.5% above. In other words, 3.5 to 6.5%. Air content tests are just as important as the other tests and checks made to determine if the concrete is acceptable. As for the frequency of testing for structures, one test for every 100 cubic yards. For paving, one test for every 2,500 square yards. But any time that you suspect low or high air content, run another test. This program covers the pressure meter, an instrument that uses pressure to determine air content. I'll cover equipment, operation, and calibration. So let's get started. Before any concrete is brought to the job site, be sure that all test equipment is on hand and in good condition. And make sure that the work site is ready for the concreting to begin. The pressure meter has a pressure-tight base to hold the concrete sample. Be sure that the base is clean, inside, outer rim, and upper surface of the flange. Remember that any buildup inside the base will alter the volume and void the test results. The cover must have a smooth, clean outer rim and flange surface. When clamped together, the base and cover must be pressure tight. Above the cover is the air chamber, and attached to it is a pressure gauge, with a dial graduated in both pounds per square inch and percentages of air content. There's a built-in hand pump for building up pressure. The valves and petcocks are for adding and draining water and for releasing pressure from the air meter. Also needed are the following: a metal scoop, a standard steel tamping rod, a standard strike-off bar, a mallet, some wiping cloths, a container for water, and a rubber syringe. For calibration, however, you'll need some more equipment: a short, straight tube, a longer, curved tube, and a calibrating vessel. All right, now let's see how to operate the pressure meter. First, put the concrete from the sample in the base until it's 1/3 full. Rod the layer 25 times, following a spiral pattern toward the center. Then tap the outside of the base 15 times with the mallet to get out the open spaces and air bubbles. Repeat the procedure of filling, rodding 25 times, and tapping 15 times for the second and third layers. After tapping the base for the third layer, strike off the excess concrete using a sawing motion. Next, wipe the flange clean to ensure a tight seal between cover and base. And clamp on the cover with both petcocks open. Now inject water through one petcock until all air is expelled through the other one. You'll know that all the air is out when some water comes out of the second petcock. Leaving both petcocks open, pump air until the hand on the gauge dial reaches the initial pressure point. Then wait a few seconds and stabilize the gauge hand at initial pressure by either pumping more air in or bleeding some off. Now close both petcocks and press down on the thumb lever. This releases the air into the base. Keep holding the lever down and gently tap the gauge with your fingers until the dial hand stabilizes. Be careful not to tilt the gauge at any time. Read the percent of air content as indicated by the gauge hand and record this percentage on the delivery slip. Now all you have to do is release the pressure and clean the equipment. By opening both petcocks, removing the cover, discarding the sample, and thoroughly cleaning the base, cover, and petcock openings. Okay, that's how the pressure meter should be operated. But now let's look at the calibration. Calibration is necessary to verify the operating pressure and to check the pressure gauge accuracy. Here's what to do. First, fill the base completely full of water. Screw the short piece of straight tubing into the threaded petcock on the underside of the cover. Clamp on the cover. With both petcocks open, inject water into the petcock with the tube attached below it until water comes out the other petcock. Pump air to a little beyond the initial pressure line. Wait a few seconds and then stabilize the gauge hand at the initial pressure line by pumping or bleeding off as needed. Now close both petcocks and immediately press down on the thumb lever. The air is exhausted into the base. Wait a bit for the hand to stabilize. The gauge should read 0%. If it doesn't, run another test. If 2 or more tests show a consistent variation from 0%, change the initial pressure line to compensate for it, and use this new initial pressure line on subsequent tests. Then screw the curved tube into the outer end of the petcock. Fill the calibrating vessel with water from the base by pressing on the thumb lever and controlling the flow with the petcock lever. Usually this vessel holds 5% of the volume of the base. Release the air at the free petcock. Open the other petcock and let the water in the curved tube run back into the base. There is now 5% air in the base, or whatever percentage is represented by the vessel. Next, with the petcocks open, repeat the steps of pumping to initial pressure line, stabilizing the dial hand, closing both petcocks, and immediately holding down the thumb lever, and waiting for the dial hand to stabilize. Read the percent of air on the dial. It should be 5%, or whatever percentage of volume is represented by the calibration cylinder. If 2 or more tests show incorrect readings, off by more than 0.2%, remove the gauge glass and reset the dial hand to 5% by turning the recalibrating screw. Keep in mind that when the gauge reads correctly at 5%, more water can be drawn off, as you just saw, to check results at 10%, 15%, and so on. And with that, we finish air content testing with the pressure meter. But just a few more points before I finish. No test is valid unless it's performed correctly, in the same way each time, using properly calibrated equipment in good condition. Use the equipment carefully without damaging it. Keep it clean. Air content should be recorded on the delivery slips. Be neat, complete, and accurate in your documentation. And finally, inspect your actions. What to do when air contents don't comply with specifications. First, be sure you know the requirements. Check the concrete design and the specifications if you are unsure. When a test result is out of specification, run another test. In fact, anytime you see or suspect something unusual, run a check test. Inspecting and testing the quality of Portland cement concrete is a big responsibility, so give it your best effort. This completes Part 3, the final program of the series on concrete sampling and testing.